hope you are enjoying our videos, and um, you are really being refreshed by the calculations we are given to you. And I really want you to stay connected so that we can equip you more and more with the videos we are going to upload. So, the last time I said we are going to discuss about projectile motion. Yes, projectile motion. This is our new topic. If this is your first time of watching our video, please subscribe, like, and place your comment. Yeah, what is projectile motion? Projectile motion is a motion of an object moving in a parabola. Let me explain it this way. It takes this pattern. Let's say you're having a vertical and an horizontal part. And now you throw an object, it moves and gets to maximum height. Thereafter, the velocity becomes zero and starts going down. Yeah. So there is what we call the initial velocity. There's a velocity that propels it to move upward. And at this point in time, there is the maximum height. And now, there's a time it started moving, the time t1, and there's a time the object comes back to the original ground again, time t2. And from here to this place, it started from a point called 0, or let me call it R1, let me call this R2. This is the ground, this is the horizontal surface. It started from the horizontal surface, and it goes back again to the horizontal surface. So the span between the starting point to the point where it hit the ground again is the range. This is the range. And then there are a lot of things we are going to consider here. First of all, when it's moving with two velocities, the vertical velocity, the horizontal velocity. Now it got to this point, it get to the what? Just the horizontal velocity. Now again, the vertical velocity, the horizontal velocity. Yes. Now but then, from here to this point is the maximum height. Now from here to this place is the range. The time with which it started to the time it gets back to the ground again is the total time or the time of flight. So you need to understand that in resolving this thing, we have the final velocity, then we have the initial velocity. There's a point whereby at uniform velocity, the final velocity becomes equal to the uniform initial velocity. But then, we'll be resolving this along the vertical part and the horizontal part. This is the horizontal part from this point to this point. So along the horizontal part now, the initial velocity is inclined at an angle of cos theta. Let me put it this way. Along horizontal part, initial velocity u is equal to u cos theta, while along the vertical part, when it's moving upward, initial velocity u, or can see uy, is equal to u sine theta. Yeah. So that's how we are going to use this principle to be resolving it one after the other. So therefore, what is the time of flight? I want to resolve the time of flight. Time of flight is actually the time taken for the object to return to its original or to the ground again. Time taken from the object to get to the maximum height and then return to the original ground again. So we are going to talk about the time taken to get to the maximum height, because we have two t now. This t1 is the time taken to get to this place, then the second thing is the time taken for the t to come back. So we have two t now. So the t between here to this point is the total time of flight, but there's a t that takes it to the maximum height. It's what we call the time of flight, or the initial time of flight. Now we can say we have the equation of motion, which is u. Our first equation of motion, we have v is equal to u plus at. Yes. Now we want to look for the time to get to the maximum height. Yes. Time to get to the maximum height, t now. Now when the body was moving, it started from initial velocity. Initial velocity prepared the body to move, of which the u that took it in a vertical direction is what? Sine theta. I told you it's equal to u sine theta. Now, when it gets to the maximum height, the final velocity is what? Is 0. And now, the acceleration with which it uses when it was going up is an acceleration due to gravity. It's negative because it's acting against gravity. So g is negative. So now g is negative. So what is the time taken to get to this maximum height now? So let's resolve it. So at this point we're going to have is 0 is equal to u sine theta plus into bracket minus a. Then we have the t. Now 0 is equal to u sine theta minus at. So let's make this t the solid formula. So minus u, this minus u sine theta will come to this other side. Minus u sine theta is equal to minus at. So let's make t the solid formula. So t is equal to minus u sine theta over minus a. So a will cancel a. T is equal to u sine theta over a. Remember, it is a if it is linear, but now it's moving upward now. So our a is equal to g. I get it because it is moving upward, acceleration due to gravity. So t is equal to u sine theta over g. So this is the time taken to get to maximum height. Maximum height. Time taken to get to the maximum height. So I can say Tm. Time taken to get to it. So what's the real time of flight? Now the time taken for this thing to come back to the ground again now is twice the time taken to get to the maximum height. So total time of flight now, or let me say the time of flight now is equal to 2 times Tm. This is my Tm. So it's going to be what? T is equal to 2 times u sine theta over g. So T is equal to 2u sine theta over g. That is for the time of flight. So this is the time of flight now. So this is the time of flight for a projectile of the body. Yes, this is the time of flight. Now, the next thing we are going to do is to find the maximum height. What is the value for the maximum height? When the object has gotten to the height, what is the value? So the maximum height now, we are going to take into consideration the second equation of motion, which is v squared is equal to u squared plus 2as. Remember, we are dealing with gravity here now. So x is equal to h and a is equal to g. I get it? Now, for you to get to the maximum height, I told you that g is negative. So the equation becomes v squared is equal to u squared minus 2g then h. We'll replace s with h, we'll replace a with g now. So this is the equation we are going to use to get to what? To the maximum height. Note here that we are looking for h. H is the maximum height here now. So now, what is u? Please permit me, I want to clean this side of the board. You can always rewind your video, you get to know what we've done earlier. So now, the maximum height now maximum height. So remember that our initial velocity that took the body from the rest to this point, which is ux equal to uy is equal to u sine theta. So let's substitute u, let's put it into the equation, and when it gets to the maximum height, the v is what? At maximum height, the velocity with which it was moving with becomes 0. So the final velocity is 0. So let's substitute into the equation now. It becomes 0 squared is equal to what? U sine theta all square. Then remember we have minus 2, then gh. So let's make h the same formula because we are looking for h. Yeah, h becomes what? Minus, when you square this becomes u squared sine square theta minus 2gh. So let's collect like terms now. So we have minus u squared sine square theta is equal to minus 2gh. So let's make this h the same formula now. I'm going to have h is equal to minus u squared sine square theta all over 2g minus 2g. So we'll cancel this. So our h maximum height is equal to what? U squared sine square theta over 2g. So this is the maximum height. This is the time of flight. This is the maximum height now. So the last one is the range. The range is actually the distance from where the projectile started from, or the initial starting position of the projectile, to the point where the projectile hits the ground again. The range. So the range now, we are taking into consideration now the distance, just the horizontal distance. So we are going to use range is equal to the initial velocity times time of flight. Initial velocity times time of flight. So what is initial velocity? Initial velocity is what? U cos theta. I told you when it is at horizontal level, from this point to this point, ux is equal to u cos theta. So what is time of flight? Time of flight is what? 2u sine theta over g. So let's substitute into the equation. The range is equal to u cos theta times 2u sine theta over g. So let's multiply this. So I'm going to have 2u times 2u to give us 2u squared, then cos theta sine theta over g. So now we are going to have r is equal to u squared 2 cos theta sine theta over g. So from trigonometry, 2 cos theta sine theta will give us sine 2 theta. So r is equal to u squared sine 2 theta over g. Remember, the maximum angle, let's assume you throw the object, is what? Is 90 degree. 90 degree. So, and that means 2 theta will give us this 90 degree, that is 45 plus 45. So now, at what point do you get the maximum height or the maximum range? So the maximum range is at r max is at theta is equal to 45. Because 45 plus 45 will give you what? 90, and sine 90 will give you what? 1. So the maximum range now is going to be, which is at theta is equal to 45, r maximum is going to be u squared over g. So those are the basic formula you need to note. The time of flight, this is the maximum height, and this is the range. This is the range. Why this is the what? The maximum range. So please take